Hello students. So today discussion in this chapter is about modern periodic table. In the previous video we completed already Lavoisier's classification as well as Daubrinier's classification, Newland's classification and Lothar-Meyer atomic volumes also. So after all these classifications as well as Mendeleev's periodic table also. So after all these classifications students, what do you think, what is the best way to classify the elements? The best way, all the previous classifications mostly done on the basis of atomic weights, yes or no? But what is the best thing? So if you are classifying the elements based on atomic weights, so what we are getting, there are so many drawbacks when it comes to the weights. So what is the perfect way of classifying the elements? So the perfect way to classify the elements students is atomic numbers, which is done by the scientist mostly. He calculated the atomic numbers, so by an experiment, and he classified all the elements in this periodic table called as modern periodic table, which is done by the scientist Henry Moseley. So like I said, modern periodic law is also same like Mendeleev's law. What is the only change? In the place of atomic weights, you have to write atomic numbers. Atomic weights is replaced by atomic numbers. Why atomic number? What is atomic number? Atomic number is number of protons in an atom, is called as atomic number, yes or no? Can two different elements, they can have same weights, right? Isobars. Can two different elements, can they have same atomic number? Is it possible? Impossible. Every element has its own atomic number. No two different elements can have the same atomic number. Got the clarity students? Understood? So that's why atomic number is the best way to classify the elements. So now look at the law. The physical and chemical properties of the elements are the periodic functions of their atomic numbers. Like same, what does it mean? Moseley also classified the elements into groups and periods, and he said the elements with similar physical properties as well as chemical properties comes in same group, but every time the element is added in a different period, that is periodic function. And ultimately all these elements are classified based on what basis? Atomic numbers, increasing order of atomic numbers from 1 to 118. So let's see the classification. This periodic table is also called as long form of the periodic table. So this is the classification students, the ultimate classification, modern periodic table. So according to this classification, you can check what is the first element. What is the element with atomic number 1? Hydrogen, right? Clear? And what is the element with atomic number 2? Helium. Clear? So see, this periodic table are classified into groups and periods. How many groups? Total 18 groups are there students. In this periodic table, how many? 18 groups are there. And how many periods? 7 periods are there. Let's count. This is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. 18 groups are there. Vertical columns are called as groups. Horizontal rows are called as periods. Let's count the periods. 1, 2, 3, 4, 5, 6 and 7. So total 18 groups. And but look at here, there is some space between hydrogen and helium. There is some space between beryllium and boron. Yes or no? Why all these spaces created? And why this periodic table is like in this shape? This classification is not just done according to the atomic numbers, but also done according to the electronic configuration, which means students, according to the Euler diagram, you can write the configuration for all the elements, right? Electrons enter into the 1s, next 2s 2p, next 3s 3p, 4s 3d. That order elements are classified. Let's see how. What is the first element? Hydrogen. What is its configuration students? 1s1. What's the next element? Helium. 1s2. First shell is completed or not? So first period is completed. That's it. Next lithium. What is the configuration? Lithium configuration is 2s1. Beryllium 2s2. Boron 2s2 2p1. 2s2 2p2, 2p3, 2p4, 2p5. Neon 2s2, 2p6. Second shell is completed. Next electrons enter into the third shell, 3s1. Next 3s2, 3s2 3p1 till argon 3s2 3p6. Third shell is also completed. Yes, sir, students. Third shell also completed. After third shell, electrons enter into the fourth shell, and elements in the modern periodic table enters into the fourth period, 4s1. Next 4s2. After 4s, elements enter into which orbital? 3d. 3d starts here. 3d can accommodate how many electrons? Total 10 electrons. 3d 1 2, 3d 10. Yes, students. So that means how many elements are possible? Total 10 elements are possible. Yes or no? Total 10 elements are possible. 3D1, 3D2, 3D3, 3D4 till 3D10. After 3D, 4p elements will start. 4p1, 4p2 till 4s to 4p6. Fourth shell is completed or not? Next elements enter into the fifth. 5s1, 5s2. Next 4d 1 to 10, 5p1 to 5p6, 5s to 5p6. Fifth shell is completed. Fifth period is completed in the periodic table. Next elements enter into the sixth shell, sixth period, 6s1, 6s2. After 6s, electrons enter into the 4f, 14. Yes, sir, now 4f, f maximum can accommodate how many electrons? 14 electrons. 4f1 to 4f14, which are placed at the bottom of the periodic table. Why they are placed, that we will discuss. So next, after 4f, electrons enter into 5d, and after 5d, 6p1 to 6p6. 6s to 6th shell also completed, 6th period is completed. Last, electrons enter into the 7th shell, 7th period, 7s1. Next, after 7s1, 5f. After 5f, 6d, 1 to 10. After 6d, 7p, 1 to 7s2, 7p6. That's how all the elements are classified in the modern periodic table, students. So now answer, is this classification a valid classification? Absolutely yes. Why? Because all these elements are clearly classified according to their atomic numbers and electronic configuration. Is there any chance for drawback? No, absolutely not. Now let us discuss the main points under this classification. So you can count the number of groups. How many groups are there? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. 18 groups are there and 7 periods are there. Vertical columns are called as groups. Horizontal rows are called as periods. So students, what the period indicates in the modern periodic table? The periods indicates valency shell of the elements. What the group indicates in the modern periodic table? The group number indicates the number of valence electrons. So let us look at the group 1. So all the elements in the same group or same period where they show similar properties, the elements present in the same group, they have similar properties. Sir, why? You can look at the configurations. All these elements have same configurations or not? S1, 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 S1. That means they have same valency shell electrons or not? Valency shell electrons are the reason for the chemical reactivity. So that's why they have similar chemical reactivity. For example, hydrogen combines with oxygen. What is the formula? H2O. If lithium combines with oxygen, what is the formula? Li2O. If sodium combines with oxygen, Na2O. Potassium, K2O. If hydrogen combines with chlorine, what is the formula? HCl. If lithium combines, LiCl. If sodium combines, NaCl. If potassium combines, KCl. That is what the similarity meaning. So the elements present in the same group have same properties because they have same valence electrons. Got the clarity, students? And main 2 points, main group number. Why the elements in the same group have same properties, same configurations, valency shell configurations. And what's the period number indicates? The valency shell. Now the whole periodic table is classified into 4 blocks: S block, P block, D block and F block. So if the last electron enters in the S subshell, called as S block elements. Now answer, how many groups are there under S block? Group 1, group 2. These are S block elements. Yes or no? Why? Because S1 configurations, S2 configurations. And what these from 13th to 18th, what this group is called as? This group is called as P block elements. Why? Because the last electron is present in the P subshell. Now in between here, S block and P block, what is this block? This block is called as? This block is called as D block. Their last filled electrons are in the D subshell, and the last one, this is called as F block elements. So the whole periodic table is classified into 4 blocks: S, P, D and F blocks. Got the clarity, students? So now all these elements, every group has its own family name, students. Every group has its own family name. Group 1 elements are called as alkali metals. Group 2 elements are called as alkaline earth metals. They are highly reactive metals, silvery metals. The reason why they are called by these names, because alkali means base. When a base dissolves in water, called as alkali. They show basic nature. Next, D block elements are called as transition elements. Transition meaning something is changing. What is changing in the periodic table? Metallic nature to the non-metallic nature is changing. You can see the left to right. Extreme left side metals are there. Here moderate metals are there. Extreme right side non-metals are there. That means from left to right, from elements are changing from metallic nature to the non-metallic nature. Yes or no? The transition is taking place or not? Through this D block. That's why they are called as transitional elements or transitional metals. Next, 13th group is called as boron family. It starts with boron. 14th group called as carbon family, starts with carbon. Next, 15th group elements are called as nicogens because these group elements, they form like not poisonous, suffocating gases, unbreathable gases. So Nico means unbreathable. Next, 16th group elements are called as chalcogens. Calc means copper. These group elements generate copper. How? Copper is a d block elements. How do these group elements generate copper? These group elements, they do not generate direct synthesis by metallurgical process. Copper in the nature mostly combined with these group elements, oxygen, sulfur, selenium, sometimes tellurium also. So while refining copper, we are separating copper from 16 group elements. Yes or no? That's why they're called as chalcogens, copper generators. 17th group halogens. These elements, when they combine with extreme metals, they form the respective salts, and most of these salts are available in the sea water. Sodium chloride, magnesium chloride, sodium bromide, all these salts. So that's why called as halogens. Last group called as noble gases, students. Noble gases or inert gases, aerogens, all these names because they are chemically unreactive. They are also called as zero group elements. Why? Because their valency is 0. Got the clarity? And aerogens because all these gases are air. There is one exception, that is helium. Helium should belong to S block element. Yes or no? It's the last electron in the S subshell, but it is placed in the P block because of its similar chemical reactivity. So got the clarity, students? So that's all idea about the group names and the families, everything and all. So total 18 groups, 7 periods. All these elements are classified not just according to the atomic numbers, but also according to the electronic configurations. I hope you got the clarity. So students, next let us check few points under this classification. The first period is the shortest period of all and contains only 2 elements. Yes sir, no? Look at the first period. It contains how many? Hydrogen and helium. Why only 2 elements? Why? Because 1s1 configuration, 1s2. Only 2 configurations are there in students. First shell, that is finished. So only 2 elements. Second period, third period contains how many elements? Check. Total 8 elements are there. Why 8? 2s, 2p, 3s, 3p, s 2 electrons, p 6 electrons. 2 plus 6, 8. Next. Fourth and fifth period contains 18. Here D block elements are starting. Yes sir, no, plus 10 you have to add. So 18. Sixth and seventh contains 32 elements each. They also belong to the sixth period. 4f belong to the sixth period. 5f belong to the seventh period. So 18 plus 14. How much? 32 elements are there in sixth and seventh. So this is called the shortest period, first one. Next, second and third is called as short periods. Fourth and fifth is called as long period, and sixth and seventh are called as longest periods in the periodic table. Now look at what are the merits of the modern periodic table, students. Already we have some drawbacks in the Mendeleev's classification. Sir, no, position of isotopes and anomalous behavior. Isotopes is a drawback there, but here also in the modern periodic table, isotopes are not classified, but that is a drawback here. Why? Because isotopes have same atomic number but different masses. Mendeleev classification is based on masses. He should classify. But here they have same atomic numbers. Yes or no? Do we need to classify with the same atomic number? No need. Got the clarity? That's how that drawback is rectified. And anomalous behavior, like iodine, tellurium, they are in the decreasing order in Mendeleev classification by weights. But look at the atomic numbers, they are in the decreasing order by atomic number. No, in the increasing order only. Tellurium atomic number 52, iodine atomic number 53. So that's how even that drawback also rectified, students. Next, all these elements, majority of the elements in the modern periodic table are metals. So like 78% of them are metals, like alkaline earth metals. Both are S block elements, highly reactive metals. Transition elements are the D block elements, moderately reactive metals. We have some least reactive metals also, like gold, silver, platinum. And lanthanides, actinides. These 4f elements are called as lanthanide, students. They follow after the element lanthanum. And 5f elements are called as actinides. They follow after the element actinum. So called as lanthanides and actinides. They are also called as inner transition elements also. You can check the name. Lanthanides and actinides are also called as inner transition. Why? Because if you want to include them in the modern periodic table, why they are placed at the bottom of the periodic table, we didn't discuss, no, students. The reason is, if this is the periodic table, if you want to include them in the modern periodic table, you know what is their position? They are here. They are just inner to the D block. Yes or no? They are inner to the, this is P block, D block. Here it is F block. Do we need to give a separate groups for these elements? No need. That's why they are not included. Why? Because most of them are radioactive and majority of them are having similar sizes, same reactivity. So if you want to include them, the whole periodic table, look at how it is elongated. Yes or no? So again, new groups will be added. The whole periodic table looks completely changed, the group numbers, everything. So to avoid all these disturbances, simply they are placed at the bottom of the periodic table. If you want to include them, they are inner to the transition elements, so called as inner transition elements. Next, elements classified as non-metals, like there are non-metals like sulfur, carbon, phosphorus, selenium, iodine, these are solids. Bromine is the only liquid non-metal. Mercury is the only liquid metal. The remaining non-metals, nitrogen, oxygen, fluorine, chlorine, hydrogen are gases from non-metals. A majority of the metals are solids. Nicogens, chalcogens, halogens. We already discussed the meanings of this name. 15th group, 16th group and 17th group elements. Elements classified as metalloids. Students, in the modern periodic table, there are a line of elements which separates metals and non-metals. They are called as metalloids. You can check the blue color. Boron, silicon, germanium, arsenic, antimony, tellurium, polonium. These group of elements, they have equal metallic nature as well as non-metallic nature also. That's why they are called as metalloids. So next elements classified as noble gases. The last group, this also we discussed. The last group elements, they have they are chemically unreactive. Helium, neon, argon, krypton, xenon, radon, all these elements are chemically unreactive. Why? Because they have a completely filled configurations. So that's why they're called as noble gases. Diagonal relationship. Diagonal relationship means similarity doesn't seen only in same group. Similarity can be seen between different groups also. Look at the second period of group 1 and the third period element of group 2, they show similarity. Why this? Why this is happening? That means they're showing similarity diagonally. Yes or no? That's why it is called as diagonal relationship. They show similarity because of similar atomic size. They're not showing similarity based on valency. Lithium valency is 1, magnesium valency is 2. Whereby not by valency, by hydration enthalpies, by crystal lattice, by melting points, boiling points, by polarizing power, by having covalent character, by forming similar type of compounds. That's how they're showing the similar behavior. That property is called as diagonal relationship. Typical elements. Typical element means mostly third period elements are called as typical elements. Majority of the compounds made up of or used or frequently discussed are from these elements only. Sodium, where we discussed about sodium, washing soda, sodium carbonate, sodium chloride, magnesium, magnesium hydroxide, antacid tablets, yes or no, used for laxative. So magnesium chloride, magnesium carbonate, also aluminium oxide, bauxite, ore is called as aluminium oxide. Next silicon, the whole sand, silica. Next phosphorus, one of the key element for plant life, yes or no, sulfur. And sulfur mainly used for in sulfuric acid. The sulfur is present in sulfuric acid. Chlorine, where chlorine is present? Chlorine is present in sodium chloride, NaCl, and chlorine gas is also used as a disinfectant. Majority of the uses frequent elements, and they are called as typical elements, students. They have the properties. Based on those properties only we can analyze the other elements properties also of the same group. Bridge elements, the elements which have properties of different groups, that is called as a bridge element. Different groups means in the modern periodic table it is like students, in the previous period classifications, these elements are summarized under same group, like group A and group B. In the same group they gave subgroups also. And even in the modern periodic table also, if you can check the old notations, they are called as 2A elements or 2B elements. So they have similarity in their reactivity. Like calcium can have +2, like magnesium belongs to calcium group only, but typical elements can act like bridge elements. Magnesium is a typical element, yes or no? And magnesium, like magnesium Mg+2, look at these D block elements, Zn+2, Cd+2, cadmium, mercury, Hg+2, they can also have same properties. So a metal which can act like a bridge between two groups is called as a bridge element. Mostly typical elements acts like bridge elements. So that's all, students. We discussed about modern periodic table, the reasons for the classifications, group, what the group number indicates, what the period number indicates, family names, S block, P block, D block, F block, everything. This chapter is very, very important. So periodic classifications are completed, but we are left with periodic trends that we'll discuss in the next video. Thank you, students.